In this video we'll deal with project management. We want to look at some of the techniques that are used in project management and to generally introduce the topic. Organizations take part in project work in order to achieve goals. That seems like a very rudimentary thing to say, but it's important to understand the context of project management. Project management arises out of the need to achieve goals. If the organization have set goals, or set routines I should say, which they perform on a regular basis, perhaps every day or every week or every certain time period, then they will have established procedures, and in a sense the project manages itself. The operators, the managers, the personnel involved will know what is required of them, and the project is well established and well understood. But when new projects are introduced into an organization, sometimes the projects need to be managed, they need to be introduced. There may be issues associated with the projects, issues which can lead to failure. There could be training issues, or there could be technological issues. There could be disruption to existing production systems as a consequence of introducing a new project. So all of this means that project management needs to be used within the organization. Project managers need to be employed, whose task it is to introduce the new procedure, to get it established, to make it a routine. It's also the case, of course, that some organizations produce highly specific projects, highly specific products for customers, almost bespoke products. These may be engineering products or indeed services within the service sector. And again, in this case, project management is important, that when the order is received, that particular order is progressed through the system by a project manager who enables the project to be brought to fruition, and as a consequence the customer is satisfied with the outcome. So project management is a very important function within businesses, one that needs careful consideration. The aim of a project is to achieve a task and an objective within a given time frame. So it may be to achieve a particular task, to ensure that a certain task is performed precisely and as required, or it may be to achieve an objective, the objective being to ensure that the whole project can continue, that it can continue without disrupting other projects, that it's going to meet the timescale that's set by the customer. So it requires a lot of thought, a lot of application, a lot of precise thinking to ensure that projects are introduced, they're progressed through the organization to fruition at the end, to completion at the end, and this all happens within the resource envelope allocated and within the time frame. Project management involves a range of activities and responsibilities and must be conducted with a team of people. Generally speaking, project management involves teams. The project manager very seldom makes the project, or makes the product. The project management brings together the skilled operators who can design, modify, produce, and who can link to each other in a team setting and pass the work in progress from one part to the next until it's completed. So the project manager ensures that the work moves along, moves from one set of tasks to the next until it's finally completed. Project management involves planning, monitoring, organizing, controlling, and allocating resources to achieve a goal or critical success factor. So the project manager knows what resources are available. The project manager also needs to plan the project? When can it be fitted in without disrupting existing production lines? When can it be fitted in when there is slack, perhaps within the system? And yet, when can it be slotted in so as not to violate a requirement on the part of the customer for delivery at a certain time period? So the project manager has got a big problem. The problem of satisfying the customer, delivering the product on time, but at the same time not disrupting other lines of production, finding slack within the system perhaps so as to complete the product. And then of course the project manager must monitor the whole process. The project manager mustn't lose sight of the work. It mustn't get lost within the bureaucracy of the organization or within the production system, or it must be monitored. It must be organized and controlled so as to pass through the various production stages until it emerges at the end as the completed product. A project is always a temporary activity which takes place to introduce new developments, new product, services and research. Project management tends to deal with newness, some innovative idea, some new product, some new way of working, the introduction of a new machine, or a reorganization of the offices, or whatever it is. The project manager is working with a new scenario, a new production scenario, and the project manager must organize the production capability of the organization to meet the customer requirements, but by dealing with this newness, this new way of organizing work, organizing the offices, organizing the system. So it's the project manager who ensures that the innovative thinking, the creative thinking, is put into practice. Now, this could be anything here. It could be the introduction of a LAN, a local area network within the business to facilitate communications. The project manager must ensure that the LAN is put in a way that is optimized for the requirements of the organization. It should not be above budget. It should be within budget, but it should meet the requirements of the organization. The aim of a project is to achieve all its goals within a given time frame and constraints. So a project is to achieve its goals, whatever the goals are, to produce so many of the items per week or per day or whatever, or to produce the single item on the order but to a very particular specification. And it's important that the organization honors its commitment to the customer by delivering within the time frame that's set and within the constraints that are set. It should also be done, of course, efficiently, so that there is profitability as a result of the activity. There are three key elements for successful project management. The quality outcome. Do quality standards and specifications meet requirements and project outcomes? It's important that the product is of a satisfactory quality specification. It's important that the customer feels that they are receiving good value for money. The output should be good quality. It should enhance the reputation of the organization. It should enable the marketing personnel to more easily find customers in the future because of the enhanced reputation for quality that the organization has built up. So it's important that the project management understand the importance of quality and ensure that the outcomes of their efforts represents good quality. Cost. Has the project achieved objectives within the allocated budget? Well, when the work was taken on by the organisation, it will have been negotiated with the customer. Or it may be that it's a product which has been put into the general market and the marketing personnel know what the price in the market should be for the product. Now, can the project managers ensure that the product is produced within budget so as to enable the organisation to produce a profit, to maintain the organisation, to maintain the stability of the organisation, and pay the owners a return on their investment? So cost is important to project management. And time. The project must be completed within the set time frame. If customers are promised delivery on a certain date, it should happen. So again, the reputation of the organisation is enhanced because it meets the deadlines that it's committed to. It's seen as a reliable organisation who's producing a good quality product within budget and delivered on time. There are different techniques used to plan, organise, monitor and control projects. We're going to spend some time, probably the rest of this session, just talking about a few of them. These are the subject matter of other videos, and you will find these other videos sprinkled throughout the course and throughout the modules. So please look them up and do some research into where we store these in terms of PDFs and videos. But the first one is the Gantt chart. Second, we'll have a look at the breakdown structure. And thirdly, the critical path analysis. And finally, PERT. So let's start with the Gantt chart. Gantt charts were introduced by Henry Gantt. They are a common technique used for planning projects. They're a very simple technique, very straightforward, and yet very powerful. They're visual, and it's important that managers can see when tasks have been started, when they're finished, when should it have been finished, was there an overshoot, were they within the time scale set, and so on. So Gantt charts can be quite sophisticated, and there are quite sophisticated ones available online that can be accessed and checked online. They range from very simple to quite sophisticated. We're going to just look at the principles here and look at a simple one in a few slides' time. A Gantt chart displays tasks and estimated deadlines. The aim of a Gantt chart is to list all tasks required for project completion. So imagine the company producing a particular product, then the various tasks that are necessary to complete that project should be listed. Right from receiving the raw materials, to issuing the raw materials, to processing on a certain machine, moving to a different machine, moving to finishing, to polishing. All of the various tasks should be listed. And if it's within the office, the same thing. The order comes through, one set of skilled personnel will deal with certain elements of the paperwork, other people will deal with other elements, and it'll be all brought together for a completed product. Each task is allocated a deadline. This then sets a possible project completion date. So once a project is received, each of the tasks are allocated, and the project manager should be realistic. How long will it take to complete each task? Without creating a lot of slack in the system. Being realistic. How long should it take? There are issues, of course, that the systems can break down, or key personnel may be away ill or away on holidays at that time, or there can be various issues that can upset the calculations. They're not always 100% accurate, so realistic estimates have to be made, and that's the skill of the project manager. Each task listed in a Gantt chart must be completed within the expected deadline. So once the Gantt chart has been developed, each task must be developed within the deadline. Each individual within the group is able to see the Gantt chart and see their tasks. So once the Gantt chart's been developed, then everyone associated with the project should be able to see the Gantt chart. They know when the project's due to start, they know when it's due to finish, and it's imperative that they meet the requirements that's set for them. Because if they don't, they're going to knock out the tasks that are coming after them. So it's important that there is precise and clear handovers of tasks from one set of workers perhaps to the next set of workers. A Gantt chart should display tasks in order. For example, the completion of one task leads to another task. Sometimes a product may require, a physical product for example, not a service product, may require raw materials, and the raw materials have to be processed on one machine. Then they move to the next machine. Well, they can only move to the second machine if the first machine has done its job. So one set of tasks depends on a different set of tasks. So it's sequential. A very simple project management chart could look something like that. This is an example taken from Locke. But here it's the creation of furniture, and you can see from just looking it over, these are the number of days ranging from 2 to 44. Different tasks. The tasks, one task starts when the other task finishes. Sometimes it's possible to run two tasks simultaneously because there are different parts to the project. But eventually they have to be assembled into one final project which is delivered to the customer. That's a very simple example. As I said, more sophisticated Gantt charts will show the start date, the completion date, it'll show when it was due, the time it's taken, whatever hold-ups were encountered, breaks in production. So Gantt charts can be very sophisticated, mostly because of the very sophisticated technology that we're now able to deploy because of advanced programming techniques that have come to play in this area. Now the work breakdown structure. Well, the work breakdown structure is a technique used to manage projects by subdividing sections of a project into manageable size, task, time frame, responsibility, and work packages. The collections of tasks that need to be done within a particular area. So the work breakdown structure it takes the project and subdivides it into different tasks. The task itself, the time frame, the who's looking after, the responsibility, and so on. Breaking tasks down into components makes planning resources efficient. It's easier to predict and make estimates, and to assign work to individuals or departments. So the order has been received, let's say, within a company. That's a big task to complete. That is the full task, to complete the order. But within that, it's possible to break it down into subtasks, smaller tasks, and then assign these to different areas of the organization, to different managers, give the managers responsibility for the tasks, get them to work on different aspects, bring it together later on to assemble perhaps into a final project. So it's possible to work out who is responsible for various tasks, to make estimates for how long they're going to deal with the particular task, when they receive it, when they can schedule it, when it'll be completed, so when will it finally go for completion, be joined to the other subtasks that are required, so it all comes together as a finished product. So it's breaking down the job into smaller components, into subtasks, if you like, and allocating those and then progressing those using project management techniques, progressing those through to the end where it can be all joined up again. A work breakdown structure improves productivity and efficient allocation of resources. It is the backbone of planning and control, really. This is the idea to take in a job and then break it down into tasks, assign the tasks to individual managers or individual operators or key personnel, and get a time frame from them, work out from the time frame what will be required in terms of subsequent time frames, subsequent periods of time, until an overall estimate of how long the task will take can be estimated. So out of this, the project manager will know when the final project can be delivered. But there is responsibility right throughout the organization. It's possible to know which manager, which operator is responsible for particular tasks. So there's accountability right throughout the system. The work breakdown structure enables project managers to review workload and what needs to be achieved. It's important that the managers know what the workload is. Perhaps some areas of the organization have to perform many tasks, that many contracts with customers for particular products will involve the use of particular resources, perhaps intensely use particular resources, and those resources should be adequately provided. There should be sufficient personnel, sufficient capital within that area, because some functions within the organization may be more important than other functions in terms of usage. Control and monitoring is easier as work breakdown structure is illustrated in a diagrammatic structure. All tasks are monitored and sequenced, so it's possible to see who's responsible for what and where the job has got to and at what stage the product will be finished. When the project is started, it may be broken down into many small tasks, again with managers responsible for the completion of those small tasks. But then when those tasks are completed, it might move up a notch, and some of the small tasks may be merged, brought together to form a bigger product, still not completed, but a bigger product, again with the manager responsible for the integration of the various tasks at the first level into the second level product, and several second level products may be then integrated into a third level right up to the finish. We'll see a chart later to try to illustrate this. A work breakdown structure is represented in a hierarchical structure, subdivision of tasks. That's what's meant here. Let's have a look at a diagram to see what we mean. Here we're building a yacht, we're building a boat, let's say, and there are different parts to doing this. So you need someone to build the hull, to build the outline of the boat itself and the bulkhead. It needs a deck, and it needs the various structures within the boat, and these have to be built. These can be assembled. If you take the first two on the bottom, these can be assembled together by the boat builder. The boat builder takes the efforts of the people building the hull of the boat, the basic shape of the boat, if you like, the framework of the boat, It takes the efforts of the people building the decks and the superstructure, and it puts those two together, and we call it the boat builder. So the boat builder is the next one up, who integrates the work of the deck and superstructure manager with that of the manager for the hull and the bulkhead. Now we've got the boat builder. And the same for mechanical engineer. We have the main engine and we have the steering of the boat. They may have other functions. We're just taking a very simple example here. This is taken from Burke. But here we have two functions, two tasks, and when they're completed, we go to the mechanical engineering section, who will make sure that everything works and that the quality is correct and so on. And we have the same for the rigger, for the sails and the mast and so on over there. And then finally, all of these three are integrated and the product is complete. But you can see from each of the boxes it's possible to have a manager responsible for each of these sections, and there are deadlines associated with each one. It would not be right if the decking and superstructure was completed before the hull and the bulkhead, because the decking and the superstructure has to go into the bulkhead. So there's a sequence there. The hull and the bulkhead must be completed before the deck and the superstructure. There's also a link between the completed boat and the steering. The steering must come after the boat. It must be built into the boat. You can't have the steering operating on its own without a boat. So you can see the complexity, and you can see the way of organizing it from this quite simple diagram. Now let's look at critical path analysis. Well, I'm not really going to look at this in great detail. I'm just going to talk about some elements of it. It's the subject matter of other videos, but let's just run through some points. Critical path analysis, it's also known as network analysis, is a technique to schedule work to minimize time. It's looking for the most efficient ways of organizing work. It looks at all the tasks to be completed and links them together to show dependency between the various tasks, because the various tasks are linked. By and large, the output from one section will be linked to the ability of the next section to improve and add to the value that was created in the previous task. But critical path analysis tries to find the most efficient way to produce the output. Now, usually it's represented in diagrams. We can see quite clearly from diagrams the types of issues involved in production, and these are joined up by arrows and different points, nodal points as we call them, to show where the work has got to and what influences are effective and where, and what issues are being confronted. So activities could say requires time and resources. Well, activities do require time and resources, and the activities are joined by arrows. Now it could be that the length of the arrow represents certain times, and it could be that an arrow that's twice as long as the previous arrow could take twice as long. That's sometimes a technique that's used. Or it may be just that the arrows drawn in and a time period written on the arrow. And the nodes, networks always start and end with a node. Nodes are represented by circles. So networks always start and end with a node. Networks, they must start somewhere and they must end somewhere. And these are the nodal points. Now let's take an example. Let's say an engineering company wishes to develop a new product. Well, we have a start point, and it could be that this is a design phase, let's say. So we have, let's say, 8 weeks, and we'll call this particular activity A. Now it starts on the node on the left, which is not marked, and it ends after 8 weeks. After 8 weeks, it goes into, let's say, production, which could be 22 weeks. So now we have a very simple example of a system here. We design a product. It takes us 8 weeks to design it, and then we make it and deliver it to a customer, which is a further 22 weeks. If you like, the whole thing will take 30 weeks. So activity A, we could say, is 8 weeks long. We call it, let's say, for argument's sake, the design phase. Activity B is the production phase, let's say 22 weeks long. So it's a very simple system. That's the node on the left would be when the task begins, and the node on the far right is when it's completed. Now, it's possible that some activities may be carried out simultaneously. For example, design and prototyping, they may be carried out simultaneously. We'll call these line AA. So we can see here, for example, that in addition to having the line A, which is getting the product ready to go into the second node, we could have design and prototyping running in parallel, which could take 11 weeks. Then the production phase could be 19 weeks, so which would take us to node 3. So what we have to do is try to decide which route to take from node 1 to node 3. Which route? Well, if we're going to integrate design and prototyping, we'd have to go node 1, AA, node 2, B, which will take us to node 3. So we can see that it's slightly more complex. Now, you can imagine in a real business there are many routes that activities take within the business, going through various departments, going through various phases of production and different layers of accountability and different processes. The whole thing gets very complicated, not as something as simple as we've got on the screen here at the moment. By the way, we can write this simply as node 1, node 2, node 3 within those nodes and get rid of the arrows. So we're starting to build up a schematic way of representing different activities within the business. And really this is to do with the idea of representing the tasks diagrammatically and trying to find the most efficient route from node 1 to node 3, or from node 1 to node 100, depending on how many different activities a product or service must go through before it's complete and ready to be delivered to the customer. Next, we'll just mention PERT. Well, this is known as the Program Evaluation and Review Technique. This is a management tool commonly used alongside critical path analysis. So critical path analysis and PERT tend to run in parallel. PERT focuses on the time element within a project. It's a planning and scheduling technique which analyzes realistic time measures. So PERT focuses on how long it takes to complete different activities and what's the most efficient route in terms of time, what's the most efficient route through the organization. So various tasks have to be completed, how should the tasks be sequenced, and what route should particular jobs take through the organization so as to minimize the time it takes for completion. PERT is designed to ensure that flexible planning has been incorporated within a project. Clearly within projects, within organizations, when a job is taken on, when an order is taken from a customer, there may be an obvious route that the job has to go through the organization. Different phases and different activities. But sometimes there may be hiccups within the production system, or key personnel may be away for whatever reason. And it's imperative that there is flexibility, that the customer will still receive the product, perhaps receive it on time, hopefully, but it means that there are different ways of completing the tasks, and tasks can be rerouted within the organization so that they are completed on time. That's a useful website to make a note of. It's a very good website, netmba.com, well worth noting and accessing from time to time. You'll find a lot of valuable notes on there. Now, using PERT as a planning tool requires the following. List all specific activities relevant to the project. So it's important that PERT, all the activities that are relevant to the project, are listed and known. And categorize the activities into sequences, one following from the previous one. Make sure there's a logical sequence of activities, one following on to the other. And devise a network analysis. This means looking at the various routes that a job can take through the organization, moving from one activity to the next activity. Perhaps it can move to different parts of the organization, be completed. What's the sequence required? Understanding the job totally and understanding how the job can be routed through the organization in the most efficient manner. Identify the time durations. Time duration must be considered based on most likely, most pessimistic, and most optimistic. So we have three measures of time. When a job goes to a particular activity, how long will it take on the activity? Well, if everything was working really well and everything is in perfect working order and the appropriate personnel are in place, that would be the most optimistic. So it would not take long to be completed. If the machines or the capital that's going to be used is experiencing problems at the moment, and perhaps key personnel are away because of illness or holidays, or have simply just left the organization for whatever reason, we're looking at the most pessimistic, so it would take longer to complete. And of course then in the middle we've got the most likely, what's likely to happen. So PERT means collecting information about what is the likely duration of a task at a particular activity, and trying to work out the overall pattern that the project should take through the organization. What sort of configuration of activities should it include so as to be most efficient? And through this type of analysis and through this type of data acquisition, a critical path could be established. Now, as you can see, I'm not dealing with PERT in any great detail here. I'm not dealing with critical path analysis either in great detail. These are the subject matters of other videos, and it's worth looking at those. So the sources that we used here, well, I've only mentioned two en route, Burke and Locke, and it's worth just bearing in mind that these are the contributors, in a sense, through their material for making of this video. That's all we're going to deal with in this session, so we're going to leave it at that and say thank you for watching.